A baseball diamond is a square with a side of 18 meters. A batter hits the ball and runs toward the first base with a speed of 7.5 meters per second. At what rate his distance from the second base decreasing when he is halfway to first base? And B, at what rate his distance from the third base increasing at the same moment? So here is our first base. So this is the first base. And then what else? We have this one here is the second base. And then what else is there? We have the third base here. Okay, so let's write all of that. And then the player is hitting the ball here and he is running there. And halfway through here, so we'll have halfway like this. And halfway, and he is running from the place where he hit the ball into the first base. Okay, and then we need to find out the distance from the second base. Okay, let's draw that. So we have to use this distance here, right? So this is the distance from the second base to this one here, halfway. Okay, and this is a square. So this is a right angle triangle, right? So here we have, let's name this here as our X. And this one here is our Y. And he is running there with a speed of 7.5 meters per second. So I will have dx dt here is equal to 7.5 meters per second. Okay? And the question is asking us about the rate of the distance from the second base. So let's name this here is Z like this. And because this is a right angle triangle, we can use Pythagorean theorem, right? So we will have Z squared and then plus, not plus, Z squared is the hypotenuse. And then we will have the adjacent side. So we will have X and the opposite side is Y. So we'll have X squared plus Y squared. And here, because the player is running in the X direction, the X is changing with respect to time. But the Y here is not changing, right? It is a constant. And we know that the length of the rectangle here is 18 meters. So this Y is 18. And so we can plug that into this equation. We will have a Z squared here is equal to X squared and then plus 18 squared. Good? Okay, maybe let's leave it as is because we need to find out the change of this Z over time, right? So we need to find out dz over dt. To get that, we need to take the derivative of this with respect to time. So I'll have this one, take derivative with respect to time. Okay, now we will have here, which is 2z here, 2z. But according to chain rule, we need to multiply it by dz dt. Because we derive this in respect to z, right? So we will need to multiply it by dz dt. And then this one here, we will have x squared, that will be 2x. And we also have dx dt. And 18 here is a constant, so we don't need to write that. And we can divide both sides by 2, so they will cancel each other. And so here we will have dz over dt here. dz over dt is equal to x divided by z. Okay, and then multiplied by dx over dt. And the question is when it is halfway. Okay, remember that the length here is 18. So when it is halfway, we know the length of x here is 9, right? So we'll have x is equal to 9. So we need to find out dz over dt when x is equal to 9. Okay, and I think we need to clean this up and use this equation here. Okay, let's do exactly that. Okay, now we need to find out when x is equal to 9. So we'll have when x is equal to 9. Okay, we have the x. We also have the xdt. What we don't have is z. How to calculate z? We can use the Pythagorean theorem. Remember that z squared here is equal to x squared plus 18 squared, right? So we'll have x squared, which is 9 squared, and then plus 18 squared, right? Because y is 18, so we'll have 18 squared. And therefore, we will have z squared here is equal to 81, and then plus 324. Okay. Okay, and then we will have z here, z squared is 405. Or we can isolate it for z, which is this one, the square root of 405. Okay, I think we can stop it here, and we can just plug in the value for this one here. What is dz dt when x is equal to 9? Okay, and then we will have the values of x here is 9. Okay, 9. And then the values of z here is 405 squared. I mean the square root of 405. And then what is dx dt? Dx dt is 7.5. 7.5, and that is hard to calculate. Let's just use calculator for this. So we will have 9 times 7.5 divided by the square root of 405. Okay, and I will have 3.35. 3.35 here, and the unit here will be meter per second. So it will be decreasing at the rate of 3.35 meter per second. So this is the answer, 3.35 meter per second. And that is the answer for question A. Okay, let's clean this up and let's answer for question B. Okay, now it is asking about what rate is his distance from the third base. So now we change with starting from the third base like this. So we will have this one here. So we will have it like this. And then this is the distance that we are looking for. And again, because this is a constant, we know that this y here is also 18, right? And then we need to find out what is dz over dt. We can still use the same y, right? Because this time we use not this x, but this x here. And because all of the values are the same here, right? We have x is there, halfway, and x is 9, and z is equal to that. We can just use the values of the previous one, right? Because all the values are the same, right? Just the distance here will be increasing, but when it is here, it will be decreasing. That is the difference. So we will have the dz over dt here when x is equal to 9, right? That will be the same. We will have 3.35 meter per second. And to get what the difference are, it is decreasing. We can use the minus sign here. And for this one, we will have 3.35 meter per second. And I think that's all for this problem. We have both the same values here. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.